Hello everyone, welcome back to my channel Ravitava Programming. So in this session, I'm going to discuss about the multi-threading uh, in Java programming. But before that, I wanted to discuss like what is the use of multitasking. So there are two different things: multi-threading, multitasking, right? So before this multi-threading, there was a multitasking concept that operating system mostly used to use. So what happens is like, uh, for example, in any case, like you will have a computer system, and in computer system there are three major part, or you could say the four major part. One is definitely the board that you are going to run. So in a laptop case, it will be like a system on chip. So this, for example, if this is a board, the board which contains the complete circuit system, and let's say this is the processor. This is the processor, or you could say the CPU. And if this is the RAM, this is RAM, and this is hard disk, which is the secondary memory. This is the primary memory, and this is the secondary memory, which is the hard disk. So all this, your operating system will be there inside the hard disk, but when you boot up, it will come into the RAM, and processor will definitely execute all the processes. So what will happen is, for example, in this case, I'm running this Docker, I'm running this uh, Paint, I'm running this Task Manager, I'm running this browser, and if I'm running this Explorer, I'm opening any folder. These are the multiple processes that are running parallelly, right? So before having your multiple cores in the processor, because earlier days, if you will we will talk about the earlier days, like the Pentium 1, Pentium 2, at that time there used to be only one logical processor. Remember that there used to be only one logical processor. So what it means, having one logical processor means, for example, if I will open this Windows and Performance, if you see, there are cores, there are different things, but in CPU there is core, right? So if you see, there are 8 cores. That means we could have 16 logical processor. In a nutshell, that means we could create 16 threads. But earlier, when there was no concept of like multiple cores, there used to be only one core, one single CPU, with ALU. So in that case, what operating system do is like they used to use the time slicing. So if you will ever read the operating system concept, so time slicing is the concept where this particular processor will divide its time for the different processes, during when that application is running. So that means, uh, so for example, this browser will take some milliseconds, this Docker will take some milliseconds, this Paint will take some time, this will take some time, this will take some time, and you will not feel that it is dividing its time to all these processes at the same time in a parallel way. The reason behind is that this particular RAM always comes in a frequency of hertz, that is the megahertz. So usually you will see that the RAM is running on 1300 megahertz, or maybe the 1600. I mean, I'm just giving the examples. So megahertz. So 1 megahertz means 1 million cycles per second. But the processor, if you see any time, the configuration, the processor always comes in a gigahertz, right? So 1 gigahertz is equal to 1 billion cycles per second, right? So processor actually always run on a very fast speed than the RAM and also the hard disk. So in this case hard disk will be always slower, so we put all the the static files which are not currently running or maybe not currently useful into the hard disk, and whatever the program is currently running that we will put into the RAM, and the processor which execute each instructions as per the need. So that's why if you go to buy any laptop or desktop or any computer, you will see that processor will cost you always 10 times or maybe more than 10 times the RAM, and RAM will be all costlier than the hard disk. So hard disk is one of the cheapest part in the any computer. So now this is how this times like slicing used to happen earlier. Now it's, I mean, even nowadays it is happening, but because nowadays we have a processor with a very high capability. That means, I mean, we have multiple cores. i3 means then there will be 3 cores, i5 means there will be 5 cores, something like that, right? Not exactly, but yeah, for the assumption you could say that something like that. So these are the the processor with the high end cores. That means it could have a multiple CPU unit within a particular CPU, or you could say the logical processors, right, with the ALU. So for example, this has 8 cores. That means my machine has, logically my machine has like 8 different CPU, 8 different CPU, something like this. So if you will compare Pentium 1 P1, which used to have only 1 core, right? Now I have 8 core. That means my machine is 8 times faster than that and that machine. So, but because all these small running these applications can be done maybe in two cores. So I'm not utilizing all these 6 cores at all. Why? Because I'm the kind of application I'm running that don't need all these 6 cores. So what happens is, like, for example, if you go to the any server, in server you are not going to run all these applications. So in servers you are just you will be running your backend application. That means you are not, if you are not using the proper application, that means you are not going to utilize your hardware in a complete way. So because these are very costly hardware system, so if you are not utilizing it, and if you are not churning out the complete processing capacity of the particular uh, uh, machine, that means you are not it is not cost effective, right? And the companies who are putting a lot of money into it, they are not getting the complete return on investment in a simple way. So what Java give you, the that you could create the threads. So in case of threads, the threads are the very lightweight processes. These are individual processes. So what you can do is, like, so if you are going to perform the 4 different kind of operation like insert, update, delete, and the select into the database. So what I could do is, like, instead of having only one application and one thread, uh, or you could simply say that one class for performing the same task, and I could create 4 different methods. Like for the insert there will be method, for delete there will be another method, for select there will be another method, and update for different another method in the same class. What I could do is, like, I could create 4 different classes. Each class will have separate method for insert, for delete, for update, and for select. And for each, for those classes I could run individually as one single thread. That means there will be 4 thread. In that way, what I could do is, like, if there will be any load on the machine, for example, if I'm in earlier case, with one single class and four different methods within that class. If I was able to run maybe 10,000 transactions per second. In this case, I could run 40,000 transactions per second. It's a roughly idea. That is what the threads gives you the capability. Also, because I'm creating the four different threads, that means I am utilizing all these cores at the same time. So in this case, if you see, I'm almost utilizing the 80% of capacity of my machine or my processor. So this is more, a better way of utilizing your hardware resources, as well as you are getting the best performance, by creating the thread. So there are different ways of creating the threads, like by using the Runnable interface and the thread class. So in a next session I'm going to discuss that. But before that, I just wanted to give you idea that how these thread works, how your operating system works. So how the time slicing is different from the threading. So threading or the multi-threading or the thread are the lightweight processes which runs individually, and it because it depends upon the processor and its capabilities. So you could actually utilize your processor which runs on a very high frequency in a best manner. And because you are creating a thread and directly you are interacting with the your processor, definitely your process is going to be very fast. So earlier, for example, for the insert update delete, if I'm going to use only one core at the same time, that means this core is actually slicing its time. Let's say there are four processes. That means it is going to divide its time into four parts, right? For those four different processes, right? So now by using the thread, I am utilizing these cores which were idle earlier, right? So this way I'm utilizing the hardware, also I'm getting the best performance from the machine. In this session I'm going to discuss about one of the method, that is start. So earlier we have discussed like the run method, sleep method. Now third is the start method. So no, sorry, not the start method, join method. So yeah, start method obviously we have discussed. So what happens is like when there is a thread class, right? So if you see, this is the first thread class, this is the second thread class, right? And what I'm doing, I'm passing it into this thread class like this, and starting these threads. So save this and let me clear the screen. So I'm saying java thread join example.java. Thread join, okay, java c, right? And I'm saying java thread join example c. Here if you see it, both the thread started at the same time. But how am I saying it? See, this T1 has method implementation, run method implementation, and it has a sleep of 5,000 milliseconds. That means roughly 5 seconds, right? But still, if you see, when I started it, it started both of them at the same time. Started at the same time. It is not waiting for the 5 seconds, right? But still, it is stopping after this thread is stopping after 5 seconds. So when I'm saying this, when I'm writing T1 start, T2 start, it is running at the same time. So when this T1 started, that means this particular thread started, it is the second line is not waiting for completion of this particular thread. This T2 which is the thread 2, is not waiting for this to complete. So it will go in a at the same time. So usually what happens is, for example, if you are writing any program in the Java code, so it will execute the first line, then only go to the second line. So it always wait, because this is always go in a sequential manner, right? But in case of thread, it will just start the thread. Now this is a separate entity, this is separate thread. It is running in the background, and after that it will execute the second thread, that is this one, and it is also running in the background. So it is not waiting for the first thread to complete. So this is how it works. But in many scenarios what happens is, like, you have to make it waiting. For example, if there are 50 threads, right, and some of them you wanted to complete and uh, uh, go further, some of them you want to complete, because the execution result of those threads are work will work as an input to the other threads. That is possible. So how we could get the result from particular thread, that we will discuss later. But for the scenarios, so for example, if there are 50 threads, let's say first 10 thread I wanted to execute in a sequential manner. I don't want to wait for them, let them complete. And let's say there are two threads which has some execution output, and I want to use them into this other thread. So what I will do is, like, I will make them complete, right, their processing. Once they will complete, they will send some response, and I will execute the other 28, right. Let's say in that manner. So in for doing that, what we have to do is we have to use join. So what I could do is, I will simply say, because these method give you the interrupted exception, so I'm adding this join into the try catch. So in this case, what I'm saying, or what I'm instructing, like, start the T1, let it complete. Once it will complete, then only you could start the T2 thread, right? So if I will execute, first let me compile this and execute. See, thread 1 started. It will take 5 seconds to complete, then the thread 2 will start running. So this is how we could make it in a sequence, so that if there is any output from the first thread, we could utilize it into second thread. That's why we use this join method. In this session, I'm going to give you one example on the thread, like how can we create Java threads through the program. So there are two ways of implementing the thread. One is we could use the runnable interface. Another is, like, we could extend the thread class. So first I will give you the example with the runnable interface. So let's say there is a class, public class runnable example, and I'm saying implements runnable. So other things we will, like, as usual way, public static void main, and string args. So because I'm implementing the runnable interface, if you could see here in runnable interface, so this is the API from the JDK, I mean Java JDK. So it's a functional interface, and we are seeing the document from the Java 8. So if you could see, there is only one method in this interface, that is run, right, and we are going to uh, override that method, so because we are implementing it. So what I have to do is I have to write override public void run method. I'm just overriding it, and I'm saying system dot out dot out dot println, and I'm saying this is runnable thread, right? And here I'm saying thread class. To make this runnable example class as a thread class, I have to put it inside the thread constructor. So I will say new thread, and I will simply pass it new runnable example. You could create a separate instance of, like, for example, runnable example runnable example equal to new runnable example. You could pass this object into it, but I mean, or you could directly pass the new object. So both are correct, there is no problem with that. So once I will pass this object, remember this, I am making the thread of the same class which I'm trying to, I will invoke it, right, through the Java command. So I'm saying thread dot start, and I'm saving it. Runnable example. As in Java C, runnable example dot Java, and Java runnable C. It is saying this is runnable thread. There are some more methods in thread class. So, like, I could set the name as well. Set name. So to this thread, I am saying this, not this, runnable example thread. So the name of this thread will be like runnable example thread, right? And but how do I see that what is the name of that thread? So in that case, what I could do is I could simply call thread dot okay, so it is current thread dot get name. So I will compile this, and if I'm running it, it is saying example runnable example thread. So let me pass some space here so that it is more visible in a better way. See, you could see the thread name which I have set it here. Now I want to see whether this thread is actually getting created or not. So for that you have to install the Visual VM, that is the software. I'm adding that video to you could, how you could download the Visual VM and install it. So now to see it, you have to hold it for some time. So for that, what I'm going to use it, there is a method thread.sleep, right? So it will always take sleep time as a millisecond. So I'm making it sleeping for 10 seconds. So the 10 seconds because it will give you error, so you have to put it inside the try catch, so you could handle it. Let's say for now I'm just giving the example. I mean, I'm catching the exception directly, the exception. I'm not using the interrupted exception. So okay, where is the error? Try catch, run, expected, try, oh catch, we missed the catch. And if you go to the visual VM, visual not here, sorry. So you have to go to there, you will find bin. If you will invoke it, probably that program ends after 10 seconds. So let me restart it again. See, this runnable example is here. So this is the proof that whenever you create a thread, it will automatically create within the VM, and once you that program shut down, that thread also will go down. So this is how you could see your thread in visual VM, in actual thread, right, whether that particular thread is running or not. So this is the proof. So another way of implementing the thread is like the thread class. So I'm going to make another class, this public class thread example. So in this case I need to extend thread class, right, and I'm saying public as usual, public static void main string args, and I'm just calling public void run method. So because we are extending, so that run method automatically comes here. So that is always part of the child class, because we are extending, we are not inheriting, we are not uh, uh, implementing, in that case, like overriding it. So I will say system.out.println. So this is thread example. So to call this, what I need to do is, because I have extended it, right? I don't need to parse this thread example class as an argument into the thread class. So what I could do is, because this is I have extended the thread, so I could directly call this thread example as a thread example equal to new thread, and I'm saying thread example dot start. Remember, there is a difference, right? So I need to save it. To that, I need to run it java c thread example dot java. So yes, java. Oh, not. thread example. See, so this is how you could create, you know, thread using the Runnable interface and the thread class. So if you see in this example, what I did is like, because I'm using the public static void main method, and that uh, the class which has the main method, I am making that class itself as a thread. Remember this, there is difference, so don't be confused by it. So what I am making, like in this example, I made this class as a thread. This class as a thread, I started it as a thread. Remember this thing, right? So because what happens is, like, when you think as a thread, right, for any new learner, you may think like how it is working, or how it is uh, creating at the back, backside of the JVM. So to understand it, you can see it like this particular class itself become a thread. In this session, I'm going to give you one real life example, like how we could get benefited from the thread, and how we could utilize the thread in a real life, uh, in the best way. And you will also understand like what is the difference between processing something from a single thread, or I would say without using the thread. If you are not using thread, definitely it is a always a single thread. Or how you will get benefits by distributing your task into the different threads. For example, if I have a machine and which has like 4 cores, roughly I could create the 8 threads. Usually threads, the number of threads are actually core multiplied by 2. Not in all the cases, it depends upon the processor as well, but yeah, in most of the cases you will say that cores is multiplied by 2 equal to number of threads that you could actual create, right? Virtually, obviously there will be multiple threads, but actual threads will be for example, if there are 4 cores, then there will be only 8 threads that you could create. So how you could get benefited from that? So let's say there is an example. I will just copy it. Let's say I have one operation here, uh, for the insert. Let's say I'm doing some database operation. I'm saying insert. There is another operation that is update. There is another operation that is delete. There is another operation that is select. Let's say we are performing these 4 different operations, and because it is one single thread, if I am doing it, uh, right, let's say I'm doing it for some, in some loop. Let's say it's a for loop, int I equal to 0 semicolon I is less than, let's say there are only 5 records, I plus plus, right? So let's say each operation is taking some time. Let's say that time is 1 second. I am assuming that it is taking 1 second. So if there are 5 records, it will take 5 seconds roughly, right? And for the update also, it will be same. Let's say for the delete also, it will be same. And for the select, it will be same. 5 seconds will be a bit higher side, because 5 okay, let it take 20 seconds, let's say. Yeah, 20 seconds is fine, right? At the end of the processing, it will take 20 seconds to complete this task. So let's compile this. Java Runnable. So it started. Let's wait for the 20 seconds. Right after 20 seconds, this process is completed. Or you could simply print here something like this: system.out.println, right? Insert record number. I will just print I here. Say there is a delete or update, and I'm saying there is a delete. And this is the select. I'm printing so that you could see it, like in live example that how it works, right? So first record inserted, second record inserted, third is something like this. So on a real, life, it will work something like this. But yeah, record could be, vary. Obviously, it is not going to take 1 second. But for example, if it is taking 10 milliseconds, and if you have like 50,000 records, then it will matter. So see, it took some time, 20 seconds to complete it. What if I will divide each task in a separate thread? Then what will happen, right? So that is what we could uh, test it. So let me do one thing. Create a separate thread class. So let's say class runnable insert implements runnable. Say create another class that is update. We don't need this. Simply change here. Say update. Say runnable. You could create another file as well, but for give you, the better picture, I'm just using it. Delete. So this is another thread. So delete. So select, and I will say select. So what I could do is, like, instead of implementing the thread here, I could do is I could simply run it, insert thread, and let's say it is update. there is insert, update, delete. Let's say delete. Delete thread. Three and four. Let's say select select four, four, three, two, two, one, one. C. Definitely, this is not going to solve your problem, but just for the example, I'm showing it to you. See, so all four threads started at the same time, and because all four started at the same time, so all will take only the 5 seconds. So ultimately, all four threads or the complete four tasks completed within the 5 seconds. So in this session, I'm going to discuss the two methods. One is the suspend, and the second is the resume. Both methods are deprecated from the JDK, but still, I mean, in case of like the interviews, people may ask like, what is the purpose of these two methods? So if you see, I have removed everything from the previous examples. So now I have a simple one thread, that is the thread one, another is the thread two. I'm just initializing here and I'm starting thread one and the thread two. And if you see, if I'm compiling this and if I'm running it, thread 1 and 2 is running. It is simply saying thread 1 and 2 is running in a sequence, because obviously I have coded it in a sequence manner. So what I'm doing is, here I'm just adding that the T1 is suspended. T1 is suspended. Suspend, right? And I'm also checking here whether that T1 is alive or not. Out.println. See, after T2, I'm checking whether that is alive or not. So if I will say T1 dot is alive, I mean, this is one of the method from the thread. And if I will say that T1 dot resume, right? So what this suspend method will do, like, it will start the thread and suspend for few, for some time. Once T2 will execute it, and it will check whether that particular thread is alive or not, then it will resume it, right? So if you see, it is saying it is deprecated. That's fine. So see, so what in this case is happening is, like, it is starting the thread 1 and it is suspending at the same time. Now T2 is started running, that execution is completed, and it is checking whether it is alive or not. It is alive, true, it is saying true. And at the end, I am just resuming thread 1 and it is executing the rest of the logic from this run method from the thread 1, and shutting down. So other way of testing, like, whether this is working as expected or not, what we could do is that, if I'm removing this suspend method from this, right, and I'm simply checking whether T1 is alive or not. Let me compile it. It is saying T1 is alive, right? So how can I make it, okay, let's do one thing. Let put some delay on the T1. Oh, sorry, the T2. So what I will do is I will simply put some delay on the T2 so that we will get some time for T1 to be completed. So I'm seeing 5 seconds and I'm compiling it. This part as well. So it is actually executing much before than that. So how can I do that? T1 start. Okay. T2. Okay, instead of putting the sleep there, let me kill it here so that it could get some time to kill it. See, in this case, first thread one is running, right? Then I put some delay so that that thread could be uh, killed. So after 5 seconds, because that is killed, so thread 2 it is saying like it is alive, and thread 2 is started and completed time. So this is how you could check whether that particular thread is live or not. And the suspend and the resume method I already explained. So in this session I'm going to explain you the yield method. So let's say there are two threads, one is the thread 1, another is the thread 2, and if I will execute at the same time both of them. So thread will one let's say it will take 5 seconds, or maybe it could be like 5 hours, or let's say 5 days, something like that, of bigger time. And if thread 2, then what will happen is, like, for example, if it is taking a lot of resources from the backend, right, maybe the database connection or something like that, then this thread 2 has to wait for thread 1 to release that resource. Remember that thread 2, let's say there is a database connection and there is only one connection and they have to share it. So thread 2 has to share wait for thread 1 to complete, because it is holding that resource for that particular time. Let's say it is taking the 5 hours, and let's say this is something will take 5 seconds, then it has to wait for that process to complete for 5 hours, so that it could take that database connection. So in this case what we could plan is, like, if there is something which is taking a lot of time or it could take some more time, then we could yield that process for some time and execute the second one. Once it will complete, we could start processing the thread 1. So this is how we could do it. So if I will compile, I will save this, and if I will compile, right, see, the thread 1 is running and thread 2 is running. But in this case, how do you know that whether that is particular thing working or not? So for that, what I could do is, like, I could put here a message after, within run, obviously within the run method. So what I'm doing is, like, I'm putting a message system.out.println, because see, if you are not running your example in a proper way, you are just understanding the whatever the concept I have explained. But if you are not really executing in a proper way, and you are not uh, you know doing in a proper way, with the proper syntax and the messages, you will not understand that concept properly. So I'm saying thread 1 execution completed here, and for the thread 2 I will say thread 2 execution completed here, right? So let's see. So thread 1 started, thread 2 started, thread 2 executed, completed the first, and because we yielded the thread 1, then the thread 1 came again and executed it's processing whatever it was doing and completed. So this is how you could yield your thread for some time so that you could prioritize some other thread. In this session, I'm going to give the example that how you could share the result from a particular thread to another thread, or you could say that this is the explanation or the example of the volatile keyword that I'm going to use it. So I'm going to change it, uh, change the current example, volatile. Let's say volatile keyword. So here I'm going to declare one variable, public, say volatile int count equal to 0. So this is the example. I'm going to remove this. We don't need here. So inside the run method, what I'm saying is count equal to 100. Let's say 100. So this is the count variable. So here what I'm going to do is, like, I'm instead of passing direct class constructor, I will create on one object here, thread one, thread one equal to new thread one. So I will pass this instance here, and I will start it, the thread one, and I will also t1 dot call join method so that I could complete and retrieve that value. So to access this volatile int variable, I need to create one getter method header with the public accessibility. So I will say public int get count, and I will simply return that value, return count, whatever it is. And here what I'm saying is system.out.println, and I'm saying count value plus thread one dot get count. Right, I'm removing this part. So I need to see this class thread moderator example, control F, this one dot Java. Here I'm saving it to CLS Java C thread volatile must be caught. Okay, I need to declare the try catch here. So let's say try space catch. I'm just declaring the generic exception. You could add the interrupted exception here. Exception example. I'm not adding anything inside the catch. Java thread volatile example. If you see, right, thread one is running, thread one execution completed here, and I could get this value from which I'm setting inside the run method to this, and from the get method I could access it. So if I wanted to use this value inside the thread 2, I could actually use it. That is what the benefit of it. So if I wanted to use it, what I could do is, like, I could create another example. Let's say thread 2 equal to thread 2 equal to new thread 2. Let me pass this. So I will have to create one constructor here, thread 2, say int count, and I have to pass that local variable somewhere here, public, let's say private int count semicolon. So I will say this dot count equal to count. So this will be located here. I could use it something like this dot count, and passing it here, and instead of directly calling it here, I could do is like I could pass this here, thread 2, right? Let me save this, compile this. See, thread 2 is running, and because I have passed that value as an argument, so I could utilize it. So this is how you pass the value between the two threads, and you could get the value from some execution response from the thread 1, or it could be anything, like we could pass it from the thread 2 to thread 1 as well. So this is how you utilize the volatile and the thread, and you could implement it. In this session, I'm going to explain you the interruption, thread interruption. So I'm going to create one thread. Let's say it's a thread example, and for this I will say thread interrupted. So this is the one example. So for this, what I need to do is like I need to put it into the while loop so that I could run it continuously for the better demonstration. So I will put into the while loop, so it will continuously running, but the condition will be whether it is interrupted or not. So for that, what I will do is like I will say not thread dot interrupted. So why I'm saying, because once you interrupt it from here, it will get true, and because it is not operator, it will make it false, so it will stop running. So this way we will know that okay, it is interrupted and it is not running. So now I have to create the object of this thread class, thread example thread equal to new thread example. So what I will do is like I will start it, thread dot start, and I will put it uh, for some time for the sleep. So I will say try and catch, and I'm saying exception ex, and I'm saying thread dot sleep, let's say 5 seconds. And here what I'm doing is I'm interrupting it after 5 seconds, thread dot interrupted, sorry, interrupt method. So let's save this, and let me, so it is saying public class, public should be declared. Okay, the class name is thread interrupt. Same thread dot interrupted, and okay, interrupted. Okay, there's something from previous. program. Let's save this, compile it, let's run it. So it is running. After the 5 seconds, see, it is stopped. So this is how you could call your interrupted method and interrupt method, and you could actually stop running your application or the thread by interrupting it. So in this session I'm going to explain the thread group. So this is a bit a bigger concept, because it's very difficult to give you the complete context of how thread groups works and how we could utilize in our real life scenarios, but I will try to add some examples. So what happens is, like, for example, because right now what we are doing is like we are just creating one or two thread, but in a real scenarios, right, when you are working with the servers and there are like multiple requests comes and there could be like different resources, it's not like that you are going to have only few threads. Remember this thing, right? And server is not like the your PC or your laptop. It's completely different with the different capacity. So let's assume there is one server, right, and it has some application, let's say, and it is running on it, and let's say there is one thread for some specific task. Let's say this is for inserting the record, and it could create max uh, let's say 5 thread, because I don't want to exhaust the capacity of my server. I need to always take care of it. Obviously it runs much faster, but it also depends like how many requests or how many re- threads per request you are going to create. So let's say per request you could create 5 in case, right? Let's say there is a REST API. For now, if you are new to the Java or the REST API, just don't care. Just think like there is a new processing is coming from the from some other sources. So let's say there is a REST API, or whatever you do in your internet. For example, you go to some website and you register yourself. You could assume like that, how that registration process at the back end. So REST API for, let's say, registration, and let's say there is like uh, per minute there are like at peak like 5, oh sorry, 100 registrations. So in this case, like how it is going to manage. So what we could do is like we could create each record or the each registration as a new thread group. So in case particular thread group is still working, and let's say new registration, first registration came, it created 5 threads for inserting. Let's say another came at this after a few seconds or milliseconds. Now it is not completed yet. Let's assume it is not completed yet. So what I could do is like I could create another thread group. In this way I could separate, like, okay, the first registration for the thread group is for the thread group 1, second registration is for the thread group 2. So in this way I could differentiate the different threads, because once it is created it is very difficult to manage like which thread for what purpose. So that's why we could use thread group for that. So so the same thing I'm going to just add one example. So let's say there is a class uh, mm, user thread extends thread class, uh, I need to create the constructor user thread. Let's pass something here. So I'm passing the thread name, string thread name, comma, also the thread group, right? And what I'm doing is like I'm passing this to the super. So I will pass thread group, comma, thread name. And what I'm saying is like once it is passed to the super, start this thread, or let's leave it here only. So I will create one main class, public class user thread group, public static void main. So, here. So what I could do is like in this case I could create object of that particular thread group. So I will do like thread group thread group equal to, let's say, group 1 equal to new thread group. Let's say pass the thread group. So it is thread group 1, and I will create the object of user thread user thread equal to new user thread. Right here I have to pass the name, that is the thread name. Let's say first user, comma, and I need to pass the thread group. See, username and the thread name and the thread group. Thread name. Let me copy it. Then here, what I will do is like I will start this thread. So I will start user thread dot start. Right. So let me save this. This is user thread group dot java. cmd cd java programming. Okay. Thread group java c user thread group dot java. So there is one error. Thread group cannot find symbol. Okay, I need to import it as well. So if you can see, this thread group is from the java.lang.class, I mean the thread group. So I have to import it. So other ways, like I could simply specify the fully qualified class name. We say it fully qualified class name. Both are fine. That's, but right now I'm not importing it. I mean, I'm not using the import keyword. I'm just using the fully qualified class name. So here I need to override, or I could simply uh, create the run method. Public void run method. So here I'm saying system.out.println user thread. We save this and compile it using hello user thread. Let me print some other things that is from the this method. So we could check like how many active thread groups is there. So for that, system.out.println user thread dot active count. So there are two threads. So let me create another one. Thread 2. Let's say 2, and I'm passing same compiling it. It is saying 3. There are 3 threads. One is like the user thread, another is the user 2, and the thread group itself is a one thread. So another method that I could use is like the list. So if you go here, you could print the active count, you could check the access, you could destroy it, you could get the name, parent name, you could make it the daemon, you could interrupt it. So there are various. So print information will give you the complete details of the thread group. So let me do that. So I will do it like thread group one dot list. See, there are two. First is and the second. So this is how you could print the details. So other useful method is like, I mean, you could make it stop, suspend. All these methods are there to perform. So you can try one by one, but I will give you probably a good example with the database or something else once we will reach there. So in this session, I'm going to explain the thread priorities. So there are 3 different priority that we could set uh, as per the thread. It is not mandatory to follow the thread priority by the JVM. It could randomly run it, but yeah, it will by default it will give you some level of priority, and it could execute the high priority thread first. So that is possible. So there are 3: min priority, norm priority, and the max priority. So norm is by default all the threads are norm priority with the norm priority, but you could set the min and the max. So let's say there is one thread, let's say it is a norm priority thread, and I'm extending thread class. I'm saying public void run method. Let's see system.println, and it is norm priority thread. It is by default set to 5. The value of the thread is 5. I'm giving it I'm creating a separate class for each thread. Norm priority. Another class. Let's copy the same class with min priority thread. This is the min priority thread. Min priority thread. Let's save it with the min priority thread. Name. I think first file I saved it as a text instead of saving it as Java. Right, change non priority thread.java. And let's create another class with the max priority. So this is with the max priority. So I will add the max here. Let's save it. Max priority. Right, and let me call another class, the main class which will test it. Public class thread priority in public static void main method string gs. Let me create the class objects norm priority thread, copy the name, new priority, the main priority, min priority, min priority, min priority, like max priority. Here also max, max. So now what I will do is like I will create, or I could simply call the thread directly, or because I have extended there, so what I will do is I will just simply call these independently first. Start method norm min start and the max start thread priority on Java, and I'm saying Java C thread priority.java. It is compiled. Now I'm running it. Java thread priority. See, first it is calling the norm, then the max, then the min. So if you see, I mean, ideally max should be the first, right? But uh, min is there obviously, because even if I'm calling it, earlier than the max, it is calling that at the end. So let's like run it again. It is same. It is same. So let me set the priority. No, I don't need to set it. What I could do is I could call, let's pass let's pass this max priority thread as the set priority. I will say thread dot uh, max, not max, this is the max, but I will set min priority. Let me do this, compiling. See, I set the max priority thread as the min priority, so it should, max should come at the end. So it's the min priority. See, it is completely random. It's not like whatever you have said will work, as per your requirement. It could run as per, its own JVM way. So in this session, I'm going to give you one example where you could, run your one thread in the background continuously, uh, until unless you don't need to shut it down, or if your application is running, then your thread will be continuously running in this case. So for that, what there are two ways of obviously creating the threads. One is like the runnable interface, another is the thread class. So I'm going to implement it by using the runnable interface. So let's say there is a class, let's say continuous running thread. I will say elements runnable. In this case, I have to override run method, override public void run method. So to run it continuously, what I will do is like I will say while, and I will make it loop. So see if in this case it is continuously running system.out.println. Right, so to call this class, I'm going to create another class, public class test running thread public static void main string args. So I'm just going to call this class thread equal to new thread. In this case, I have to pass that runnable class object new. You could create the instance and pass that instance as well. I mean, both are fine. To save the time, I'm just passing the functionality start. So if you see it, it will test running thread.java, test running thread.java. We compile this java c test running implements type. So java test. See, it is continuously running, and until unless you will not, give some interruption or external force, it will, not stop. So in the same way, you could, call this kind of, you could create this kind of class in a servlet, or if you are going to implement it in a some other framework, you could simply create the thread by using this. So this is the simplest way of creating a thread, and which is continuously running on the background, and based on the logic you could put different kind of logic inside the while loop by calling some method, and you could run it. So we could also make our thread as a daemon thread. So daemon thread are actually those threads which are supporting the other threads in the background. It is continuously running on the background. Once the main other threads are completed running or finish their job, so it will automatically shut down by the JVM. So you could set your thread as a daemon, or you could make it thread as a daemon thread by using simply thread dot set daemon. I will give you a better example, once we will go into the, more complex topic. But for give you the some reference, I'm just making this thread as a of this. I need to compile this. So there is no background. So because there is no other thread is, uh, running in the background, so it is shutting down. So okay, so let me do the same by calling this before that. And I will do is like I will make the like one, and I will start it here. See, it is continuously running, and thread is daemon thread is also running. So to give a more context, control C, let me pass the argument as well. So let's make a constructor of this public. Let's say give some name, public string name, and let's pass this here as well. This dot name equal to name, and I'm passing this dot name. And what I'm doing is like I'm going to pass the name here, normal thread I would say, and here I will say daemon thread, thread. So daemon thread will run, and what I could do is like I could put some delay here so that you will get better context. Exception. Here also I need to I will say thread dot sleep for, let's see, 1 second. It will make it sleep for 1 second. Thread start, thread 1 start. This is also fine. So let me compile this class and I'm running. See, normal thread, daemon thread, both are running parallelly at the same time. Now what I want to do is, like, I want to make another thread which will run after this. Thread 2 to I will say thread 2 dot start. So see, normal, second thread and daemon thread all are running. Now what I want to do is, like, I want to shut it down. I want to shut down thread 1 and 2. Then let's see what will happen. So what I will do is, like, I will pass one more argument here. So I will say public boolean status equal to, by default I'm making it true, so it is, instead of like passing this, I will set it from here. And what I will do is, like, I will pass this as an argument as well. So this is status, so I need to make this dot status equal to status. Okay, and what I am doing is I'm passing the name and I'm passing the true here. Here also I will pass true, but in case of second I'm passing false. Now here also I will pass false. Right, so thread 1 and thread 2 will stop, but let's see, because this second one is the daemon thread. Let's see whether it will automatically shut it down or not. So I'm going to compile this. Now I'm running it. Running daemon thread. So it only runs only one time because I'm passing it as false. So daemon thread also stopped automatically. We don't have to stop it by our own, because if supporting threads are not there, daemon thread will not survive. So in this session we will try to understand the whole life cycle of thread. So basically when you create a thread, and you run it, if you remember, we were using different methods, right? We were implementing the runnable interface or extending the thread class. In that case we were using the run method. Another method that we were using, like whenever we are starting any thread, we were using the start, then there was yield, then there was stop, then there was resume, there is suspend, sleep, wait. We were using all these methods. So whole all these methods actually create the complete life cycle of a thread. So whenever you create any thread through Runnable and the thread class, when you create instance and you call the start method, it will simply start a new thread. 1 second. It will simply start a new thread with no new, or you could say newborn object, right? uh, Object or a thread, simply, right? And when you start and it will call the run method, it will simply go into the running state. So uh, I would say uh, runnable, let's say runnable, or the running, uh, not running but the runnable. So it will call the runnable method, run method from the runnable interface, or the run method from the thread class. So it will simply go from here to here, right? And when it will start running it, it is simply running that thread. It is running that thread, right? And you have seen, like, we were running the different loops to print, or we were simply trying to print the value. That means that particular thread is running. Yes, right? Sequence will be this. Remember this. So, or I could add something like this as well for the better clarity. So it will go from here to here. Now from here we were either killing it or the blocking it through the different method. So uh, I will say either it is blocked in some way, because we could use the different method for suspending the thread, right? Or we could make it sleep. Or once everything is completed, we were simply killing it. So you could say the dead state. So in this case, what is happening, like, it is blocking. We put the arrow, right? It is blocking, or we could make it run it again. So different method that we were using for performing all these tasks. So after this, it could simply either, right? So after this, it could simply either killed, or put it, we could put it into the state, dead state. There is possibility that as soon as you create a thread, it will go into the dead state. That is also possible. So this direction, but obviously dead will not run. That is for sure. So we could either put it into the block from here as well. So for that, we were using different method. One is the resume, another is the notify, and here we were using suspend method, sleep method, or we could use the wait method, right? So these are the yield is another method. So yield method is also there. So, and here we could stop it, and for starting, we were using the start method, if you remember. So this is the whole life cycle of your thread. So it will start with the start, it will call the run method inside the runnable or the thread class, and it will run. We could put it into the yield, suspend, sleep. We could resume it, notify it, or we could put into the block state. And after completion of that particular process, completion of that task in the thread, it could simply go into the dead state. So this is the whole life cycle of the thread. This is the end of this topic. For more videos like this, please like, share, comment and subscribe my channel. I will see you in the next video with another interesting topic. Thank you for watching my videos.